Hello everyone, I am Dr. Sanjay Raval, Director and Chemistry Faculty of Narayana IIT and NEET Academy, Preet Vihar and Noida branch. During my discussion with the student and the complete analysis of their errors at our center, what I observed that most of the student does mistake in comparing to the basic strength of amines. The probability of errors increases when the question is related to the basicity of aromatic amines. इस चीज को ध्यान में रखते हुए कि बच्चों को ये सभी टॉपिक अच्छे से रिवाइज हो जाए, वी हैव टेकन द इनिशिएटिव टू प्रोवाइड वीडियो एक्सप्लेनेशन ऑफ सम टॉपिक्स टू आवर स्टूडेंट्स. So now, in this particular video, I am going to explain how you decide the basic strength of aromatic amines. See, the basic strength of amines depends on the three factors. One is electronic factors, and these electronic factors are inductive effect and resonance. Second is hybridization, and third is steric factor. Let us discuss all these factors one by one. Now, first we'll discuss the electronic factor, that is inductive effect. What is inductive effect? Polarization of sigma bonding electrons towards more electronegative element is called inductive effect. So it is a polarization effect. On the basis of the direction of induction, this inductive effect is divided into two types, plus I effect and minus I effect. Polarization of electron towards group is minus I effect, and polarization of sigma bonding electron away from the group is plus I effect. As far as the basic strength is concerned, the basic strength of amines depends on the protonation and deprotonation of NH2. That means the basic strength depends on the electron density around nitrogen atom. As the electron density around this nitrogen atom increases, tendency of protonation increase, therefore the basic strength increases. Now, the electron density around nitrogen in these three compounds, aniline, paramethyl aniline, and parachloroaniline, depends on neighboring groups. See, what is the difference in these groups? Benzene ring is common, resonance is also common. Therefore, the deciding factor other than resonance. And that factor is the substituent at para position. So here we have methyl group, which is an electron donating group, which donate the electron to the ring through plus I effect, which is operated by sigma bonds. And because of this, the electron density around this nitrogen increases. So in comparison to aniline, this compound undergoes protonation at higher rate. Therefore, this methyl group increases the basic strength. And thus, this paramethyl aniline is more basic than aniline. However, in parachloroaniline, chlorine is more electronegative in comparison to carbon. So this chlorine takes the electron from this carbon. So polarization of this CCl bonding electron is towards chlorine. which further propagate and takes the electron from here. So this presence of this chlorine atom decreases the electron density around the nitrogen due to their minus I effect. And there is no such factor in case of aniline. That is why parachloroaniline is less basic than aniline. So now we can say basic strength is directly proportional to plus I effect and it is inversely proportional to minus I effect. If you want to compare these compounds in decreasing order of their basic strength, this is first most basic. After that, we have aniline, second, and parachloroaniline, least basic amongst these. Now, the second factor is resonance. How resonance affect the basic strength of amines. See, when we compare aliphatic amines and aromatic amines, like say suppose, if you want to compare the basic strength of this amine and aniline. Aniline. So in aniline, lone pair of electron takes part in resonance with a pi bond obliquely due to pi lone pair conjugation. And there is no conjugation in this compound. That is why there is no resonance. Why? However, this compound takes part, this lone pair takes part in the resonance. And delocalization of this lone pair of electron with a pi bond decreases the possibility of the protonation of aniline in comparison to this compound. That is why aniline is less basic than aminocyclohexane. So this is the order of their basic strength. That means if lone pair of electron takes part in the resonance, the basic strength of compound decreases. If you want to compare the basic strength of pyridine, pyrrole, and aniline, all are base. They have lone pair of electron at nitrogen. But in case of pyridine, the lone pair at nitrogen do not participate in the resonance. Because there is pi-pi conjugation, so resonance is inside the ring only, and lone pair of electron do not involve in the resonance. However, in case of pyrrole and aniline, the lone pair of electron takes part in the resonance. Now, therefore, pyridine is most basic amongst these. But if you want to compare the pyrrole and aniline, in case of pyrrole, the lone pair of electron is a part of aromaticity. It involved in the aromatic ring. Aromatic ring. It is a part of aromaticity. And aromaticity is the extra stability of a conjugated system inside that. However, in case of aniline, yes, lone pair of electron takes part in the resonance, but do not involve in aromaticity. There is no extra delocalization, extra stability of this lone pair of electron called aromaticity. That is why aniline is more basic than pyrrole. So again, if you want to compare these compounds in decreasing order of their basic strength, pyrrole is most basic. After that, we have aniline, and then we have pyrrole. Like inductive effect, the basic strength is directly proportional to plus R effect and inversely proportional to minus R effect. This is resonance factor. Now, the third, which is a very important factor, is steric factor and hybridization. Now come to the hybridization. How this hybridization decides the basic strength when you compare the basic strength of ethanamine, imine, and cyanides. Look at in this amine, this carbon is sp3 hybridized. Here, this carbon is sp2 hybridized, and this carbon is sp hybridized. And see, there is a lone pair of electron at nitrogen. As we know that s orbital is nearest from the nucleus. Nucleus, the order of orbitals is sp df. So s orbital is nearest to the nucleus, and as the percentage of s character in the hybridization increases, that means electron comes closer to the nucleus. If electron comes closer to the nucleus, that means electron withdrawing capacity of that particular carbon increases. So here in first ethanamine, when we calculate the percentage of p character 75, and here percentage of p character is around 66, and here we have 50% because there are two orbitals, out of them one is p. So as the percentage of s character increases, electron comes closer to the nucleus. As the percentage of p character increases, electron withdrawing capacity of that carbon decreases because the distance from the nucleus increases. So in general, we can say as the percentage of p character increases, basic strength increases, or as the percentage of s character increases, basic strength decreases. So again, if you want to compare these compounds in decreasing order of their basic strength because of maximum p characters, this is more basic in comparison to this, and this is more basic in comparison to this. Now, the next point factor will play a very important part while deciding the substituted basic strength of substituted aniline is steric factor. What is the steric factor? Steric factor is basically the interaction or the repulsion between the electronic field of substituents. Say, when we compare NN dimethylaniline, 2,6-dimethyl aniline, and NN 2,6-tetramethyl aniline in the basic strength. Here, this is 3-degree amine, and because of the plus I effect of the CH3 group, plus I effect of the CH3 group, electron density around this nitrogen is more in comparison to this nitrogen. No doubt there is a plus I effect of these CH3 too, but these CH3 groups donate the electron to the benzene ring, and overall this phenyl group is electron withdrawing. And this is a symmetrical, both symmetrical compound. The electronic field of hydrogen is not so dispersed. That is why there is no much repulsion between the electronic field of hydrogen and the electronic field of methyl. Therefore, the first compound is more basic in comparison to second compound. But what about this third compound? But and say suppose if one of the methyl group is present at the ortho position, say this nitrogen is sp3 hybridized, and there is a lone pair of electron like this one, lone pair of electron with a pyramidal geometry. This bond angle is around 107 degree. But because this methyl group is present at ortho position and due to the repulsion, and here we have only hydrogen, and this is unsymmetrical compound. So because there is more steric repulsion between the electronic field of this methyl group and electronic field of this hydrogen in comparison to this area. Because here the steric interaction between their electronic field is relatively more, and the lone pair of this nitrogen takes part in resonance, and as we know that these p orbitals are perpendicular to the plane of the ring, like this one. They are perpendicular. This is pi bond in benzene. And here the orientation of this lone pair of electron, which involve in the resonance, the orientation is almost parallel to the pi orbitals of benzene ring. And this electronic interaction basically enhance the possibility of this lone pair of electron to take part in the resonance. Therefore, the basic strength of ortho-substituted aniline decreases because the possibility of this lone pair of electron to take part in the resonance increases. However, if substituents are present at both of the ortho position, now again the structure becomes symmetrical and there is equal electronic interaction from both sides. And if bulky group is also present in the amine, like in this compound, they are if they are planar, then they have dispersed electronic field, and the electronic field of these methyl groups, electronic field of these methyl group interact with each other. This interaction of the electronic field of methyl group is called steric factor or the steric effect. And because of this steric repulsion, these methyl group now perpendicular to the benzene ring. And if you maintain almost pyramidal geometry, the orientation of lone pair of electron becomes like this one. And here this ring is planar, where pi electron are perpendicular to the pi electrons are perpendicular to the ring, like this one. In this compound, this lone pair of electron align with the in the same plane with the pi electron of benzene. That is why the probability and the possibility of resonance increases. And here the basic strength decreases. But if both of the position blocked by some bulkier group, and bulkier group is also present at nitrogen, now these nitrogen bulkier group at nitrogen are perpendicular to the benzene ring, due to which the lone pair of electron is away from the pi electron of benzene, and therefore the possibility of this lone pair of electron to take part in the resonance decreases, and because of this decreasing ability to participate in the resonance, this lone pair of electron easily available for protonation, and the basic strength here increases. So if you want to compare the basic strength of these compounds, this compound is most basic, and after that this, because plus effect of 2 nitrogen plus effect of 2 CH3 group increases the electron density around this nitrogen, and here the overall phenyl group has minus I effect. So this is least basic amongst these compounds. This factor is called steric factor. Now, the another important part, say for example, if you want to compare the basic strength of these amines, as I have already discussed, because of the steric repulsion at one of the ortho position and electronic effects, the lone pair of nitrogen effectively involved in the resonance. Therefore, the basic strength of ortho substituted is less. So, if you want to compare methyl, 3-methyl, and 4-methyl, means metamethyl and paramethyl aniline, methyl group at meta position exert only plus I effect. However, at ortho position exert both plus I and hyperconjugation, but also steric factor is there. At para position, the operating effects are plus I and plus H. So now compare for one, I'll give you 1 minute to compare out of these three compounds, which one is expected to be most basic. So I think paramethyl is more basic. Paramethyl is more basic than meta, and meta is more basic than ort. So this is out of first three, para is more basic. When you compare N-methylaniline, again the resonance is common. But because of the plus I effect of this group, and here also there is a plus I effect, but distance of the plus I effect, distance of the CSA group from the nitrogen is more. Therefore, this plus I effect in comparison to this plus I effect is less. So, in case of third, there are two factors which increases the basic strength. In first, there are two factors which increases the basic strength, but steric factor decreases the basic strength more effectively. So therefore, the paramethyl aniline is most basic. And because of this steric effect and electronic effect, the involvement of this lone pair of electron in case of ortho is more. That is why their basic strength decreases. This effect is called ortho effect. So this is least. If you want to compare metamethylanine and N-methylaniline, here the operating effect is plus I, because you know that meta position रेजोनेंस में पार्टिसिपेट नहीं करती है। एंड क्योंकि देखो यहाँ पे डिस्टेंस कम है, यहाँ पे डिस्टेंस ज्यादा है, प्लस आई इफेक्ट का मैग्नीट्यूड यहाँ पर ज्यादा होगा, इसको सेकेंड पोजीशन पे बेसिक स्ट्रेंथ में आना होगा। एंड दिस इज एट थर्ड पोजीशन एंड दिस इज एट फोर्थ पोजीशन। दिस इज द ऑर्डर ऑफ देयर बेसिक strength. Now try yourself, try to compare these compounds in decreasing order of their basic strength. And if you want more content, more question, more practice, and मेरे से और कनेक्ट करना है और क्वेश्चंस या और कोई डाउट सॉल्व करना है, विजिट और प्रीत विहार and Noida Center of Narayana IIT NEET Academy. Thank you.